Loud. Okay, here we go.
Hello, I'm Hendrik. I'm a research scientist at IBM Research in the MIT IBM Lab. And I'm working on explainable AI visualization, which is my original background. And I have also a great interest in generative models across all kinds of modalities, from text to images and their combination, etc. But this is not an introduction about me. This is an introduction about our keynote speaker, Sarah. And I remember I vividly got to know of Sarah through her work in the Gen Studio project, which in our group created quite some attention, and we were really eager to see this project live and play around with it. I assume she will talk in the keynote about it. She is in a very modern sense a classical researcher, combining multiple disciplines. Yeah, so starting from neuroscience, machine learning, the arts, etc. And this is just a very fascinating combination. And of course, that makes her the perfect fit for this workshop. And just get me out some facts about her here. So she's currently a postdoctoral researcher at MIT CSAIL. She recently completed her PhD in brain and cognitive sciences at MIT, where she was advised by Josh Tenenbaum and Antonio Torralba. Her work investigates generalizable representations for vision in biological and artificial neural networks. And she's also currently the research lead in the MIT Museum Studio, where she's teaching a course on vision in art and neuroscience. She's earned a BA in computational and applied mathematics and cognitive sciences from Rice. And her prior life before MIT was in theoretical neuroscience. As I said before, she's playing on all fields, and I think you're just about to hear a super interesting keynote talk. Without further ado, Sarah, welcome. Good to see you. And you just have to indicate if you are fine with being interrupted with questions, and we would use the hand raising features in Zoom, or if we do questions afterwards. Both is fine.
Interruption is welcome. I'd love for this to be more of a discussion. The only thing, I'll get set up sharing my screen here in a second. And the only thing is that sometimes in screen sharing mode on Zoom, it's hard for the presenter to see hand raises. And so Hendrik, I'd invite you to nudge me if somebody's raised their hand, but I can also pause at a couple of places for questions. And then of course, we'll have more time for that at the end. So let me share my screen. This will stop your screen sharing. That's fine. Okay. Great. Okay, thanks, Hendrik. And it's such a pleasure to be here today. I'm really looking forward to the rest of the program and all of the wonderful presentations and to our discussion after this talk. And some of you might have noticed when looking over the program that my subtitle references a book by the late Norbert Wiener, The Human Use of Human Beings, which is a treatise on cybernetics that was published some 20 years before the invention of the internet. And in this book, Wiener claims that communication between human and machines is destined to play some increasingly large role in society, which it certainly did in the second half of the 20th century. And he argues that automation will be beneficial if we can find ways to cooperate with machines that would free us from manual labor and let us do more creative work, like making art and creating new knowledge. Well, now it's 2022, and even though we don't yet have robots that can put our groceries away, we are collaborating with machines to make art, some of which is sold for millions of dollars. So I think Wiener also got something else right. The description of processes for creating and enacting structure that can be implemented, at least at some level of abstraction, on both biological and non-biological machinery. Now, where that's relevant to us is perhaps in the potential this century to collaborate with executable versions of our own artistic or creative identities, be they individual or collective, that are implemented in parallel to us on machines. For example, in a trivial case where I train a language model on both my own poetry and the text of this book, and sift through its output to find something that feels both recognizable and new. Now, there's a contemporary tendency to kind of romanticize art as a last vestige of the truly human in an age of increasing automation like this, as some kind of spontaneous outpouring of creativity, as opposed to something more mechanistic or procedural. But ask an artist, and their creative process is a very intimate or very human thing. And its characteristic set of mechanisms serve as somewhat of a structural signature or a blueprint of an individual creative style or identity. And I'm suggesting today, somewhat as a provocation, that we're at a point where machines can learn to reproduce some of these structures, allowing us to uncover and represent facets of human creativity. Now, to ground this all in its real-world implications, I want to start with a story. In 2016, I collaborated with a visual artist to try a version of what I just described, and used a set of their artworks to learn a model of part of that artist's generative process in an exploration of their identity. And that model could be implemented on a machine running in parallel to the artist and create new works in their style, which itself was particularly predisposed to being modeled this way. And we even set up a robotic drawing system to physically realize some of the works and hang them next to the artist's own training data. Now, the model ended up producing beautiful work. And looking back, I think it was better than any of us expected. Now, this was before StyleGAN and before Clip. And the output was visually indistinguishable from the artist's original material, which to me was a delightful and a historic thing. But the response to these machine-generated works from the artist I was collaborating with was quite different. And in order to open the exhibit that we'd prepared, I had to sign an agreement with the artist that halted any continuation of the project and prevents me still now from showing any of the generated artworks or scientifically publishing the process. And now most traces of the work have since been taken down from web pages originally hosting them. Now, although it represents just one corner of the space of possible reactions to encountering a model of one's own work, this outcome raises some really interesting questions, ones that I don't necessarily have answers to, but which I hope make us think about the broader creative ecosystem surrounding collaboration with deep generative models, largely an ecosystem that rewards individuals and lacks purchase for creative operations that are distributed across humans or across humans and machines. And it could be difficult to imagine how a collaboration with digital you might play out in this ecosystem, especially as tools and technologies for implementing AI models are often long collaborative chains, and only in rare cases fully under a single artist's purview. So if AI enables us to model parts of the creative process and run them in parallel to artists, what is the legal status of these process level representations of artistic identity? Who decides what happens to the output of an algorithm? What if that algorithm were trained on works from many humans, so its output didn't look quite like any individual human artist? It's important that we consider these questions because this story to me is part of a broader narrative of fear of a future of replacement, a future that doesn't necessarily have to be. So to help equip artists and programmers to start navigating these questions in some of their own projects, I worked with colleagues at the Cyber Law Clinic at Harvard to release a pair of legal templates for collaborations where AI models are trained on existing art. And these templates are more of an invitation to facilitate collaborations in a way that's approachable and fair, and one step toward an ecosystem of attribution. And if you visit this link, you'll find a pair of templates. One is a short license for artists who won't otherwise be involved in a project, but want to license their work as input to a machine learning algorithm, with stipulations for what to do if the algorithm ends up producing outputs that are too similar to the artist's own. And the second is more of a longer collaboration agreement for teams working more closely together that first distinguishes between the code for an untrained model, a trained model, and then any outputs that trained model makes. And the agreement is set up so that the collaborators co-own the trained ML model and its output. In copyright terms, this is a joint work, meaning that all parties can use the materials however they want. And the template lets you put some limits on that and requires everyone to agree before code and outputs are used for things like commercial advertising. And again, these templates are just a small step toward thinking about culture as a shared resource and toward normalizing these kinds of networks of attribution that we need instead of notions of sole authorship. And another recent project I love, Joel Simon's project, is ArtBreeder, which takes another step in that direction. And as you've probably experienced, images on ArtBreeder are created by tuning genes of some pre-trained model's feature space, usually by starting with an image that another user created. And take any image and you can visualize, like I've done here, the long lineage of works that preceded it, which can be as recent as hours ago and as far away as years ago. But ArtBreeder is actually doing another very exciting thing here, buried beneath all of the beautiful pictures in the terms of use, where any user who discovers an image in latent space is not only the owner of that image, but as such, they automatically release it into the public domain. So they're CC0 licensed and can be used by others in future creations, both on this platform and elsewhere. And this process kind of makes explicit the collective curation of a feature language that I would argue underlies much of artistic creation, not just when we are explicitly interacting with a generative model. So we can think about modeling creative work across different scales when we're training deep generative models, specifically on works that humans have created. At one level, with individual artists like we've discussed, and of which examples abound. A few notable ones are Helena Sarin, who's unique in that she often trains her own models on her own data sets. So she's a painter and sometimes uses paintings that she has created. And Robbie Barrett, who recently collaborated with a French artist who paints skulls and trained a model to produce infinitely many skulls in that painter's style. And Pierre Wiig, an artist who I'm currently working with on an exhibition for Kistefos in Norway to both simulate and physically fabricate sculptures generated by a model trained on 3D scans that the artist manipulated, scans of an island in a Norwegian fjord. But we can apply similar techniques, and in some sense, it's easier to work with large archives of creative work, which capture collectively curated human culture. And at face value, this suggestion or tools like ArtBreeder seem very new, making use of recent tech and tools, right? But running a model for making, if you'll give me that term, and cultivating those models as part of shared cultural heritage is not new at all. And to see this, we can briefly travel to the ancient Near East, so Mesopotamia at about 2500 BCE. And there, we find a culture that accepted in-betweenness to a degree that most of us today generally do not. And not only are many of the art forms chimeric, as you can see here, exploring the spaces between known objects and concepts, but many of these objects were created ritually, where the creation of beauty is about enacting a beautiful process, something that's passed down generationally and fine-tuned between generations. And the objects themselves, like this ceramic vase on the end here, were not emphasized as the result, right? They were often buried or maybe even ritually destroyed. And so it was a style of making that much more emphasized process and iteration of a process over product, something that I think we see reflected in culture around using deep generative models for making today. And one of my favorite ancient objects that's also in the Met collection is this set of cylinder seals, which are interesting. They're hunting scenes, maybe carved on a round surface in mirror image. And then the narrative scene repeats potentially infinitely when it's rolled out across clay, right? And so you have a model here that can be repeated on myriad different surfaces and produce infinitely many versions of some underlying concept that has cultural meaning that was curated by early society. And I learned about ancient Near Eastern culture in conversation with Kim Benzel, who's head curator of the Ancient Near East collection at the Met, when I was doing the project that Hendrik mentioned, the Gen Studio project I'll discuss in a moment. And one of the things we came to realize in conversation together was that these modes of ancient making were not all too dissimilar, as I mentioned, from potentially modes of interacting with shared models of collective cultural heritage. And that maybe if we get our ecosystems of attribution right and our modes of contribution to shared models right, we could even think about deep generative models for making as sort of a renaissance of this kind of ancient mode of making, so to speak. So to give you an example of that, I did do this project with the Met. So it started back in 2017 when the Met was one of the first museums to release a public domain digital collection of all of the works, or most of the works in their physical collection that had been scanned, right? And so this was released as an open access catalog And I led this collaboration between the Met, Microsoft, and MIT to think about ways that we could use this digital collection of heritage objects to create a new, right? And to use it as a platform for future creation and iteration of this archive. So we asked when approaching this project whether we can build deep generative models, not only of a single artist's style or of a single style of data set, but with a full archive of creative work, which would let us do a number of particularly interesting things, collaborate with that model to iterate the archive forward and imagine what might come next if creation were to continue in the way it's represented in that archive. And also ask whether we could find underneath that model a feature language that underlies the instances in a collection, helping us maybe, if we can interpret dimensions in that model, understand something about a shared picture language that might have emerged in different civilizations across time or in the same civilization at different points in time. So to do this, we took those images in the digital collection and first tried training a GAN on them, right? But this is a scenario that's not all too uncommon, where data sets are not large enough on their own to produce well-trained GANs. And so one approach that we found useful here was to ask whether we could find corresponding subspaces of larger trained models that kind of approximated our data set. And so one subcategory of the Met Digital Collection is this category here, ewers, which are just varieties of different vases and pitchers. And it just so happens that this ewers category and a number of others in the Met collection are also shared by Big GAN ImageNet, strangely enough. And so we took an approach where we embedded the objects in the Met Digital Collection into Big GAN and minimized the loss at both the pixel and semantic level. So capturing these kinds of image level as well as semantic attributes of the objects in the Met collection. And in doing this, we were able to end up visualizing objects in the Met through Big GAN and achieve relatively robust representations of them that allowed us to do a couple of interesting things. And one of those is to interpolate between objects in the existing collection. And in doing that, hypothesize objects that might have existed based on objects that did, but that we might not have uncovered historically, or that might not have ever been made. And in doing this in a way that embeds objects in their historical context, we're able to make kind of precise historical hypotheses about what might have happened had two cultures collaborated. This was one of the great things about working with the Met, that curators spend their lives imbuing these collections with contextual knowledge about art making and about the cultural context of pieces in the collection. And in working with museum archives, for example, or rich data sets that contain this kind of metadata, we're able to kind of make more principled interpolations between objects in some GAN's feature space. And that tool was actually quite interesting to art historians themselves who were worried about making just Frankenstein mashups of random objects. We asked whether we could do this in sort of a more curious historical way. And when you look at the outputs of these models, one of the things that struck me is the similarity of looking through output space in a generative model to exploring what's called the open stacks or the archives of a museum. And many museums have these kinds of visible storage collections where you walk down the aisles and you see objects parameterized by small variations in detail, like glasses with a handle moved slightly up and down the right side, or silver with spoons of varying curvature. And many museums have these, and they suggest that underlying the collection that's visible to the public is some sort of a feature language suggested by objects that might not be out on display, right? And one of the things I think that's so powerful about interacting with deep generative models in this context is that we're able to actually learn an executable version of this feature language, which seems to me like organized constellations of possibility based on what was made, that allows us to do a couple of very interesting things with archives, right? As we saw, it allows us to interpolate between objects in the existing collection and kind of fill out the spaces between them, finding echoes of objects that could have been created but never were. And it also allows us to iterate or experiment with thousands of variations and select feature combinations that drive the next generation of outputs, evolving collections forward. And so I'm inspired by the idea that archives of the future might also contain models or recipes for their own evolution, right? So we could have iterable archives that could suggest how creation might be extended based on what already exists inside some collection. Whoops. And we did end up actually showcasing this in the Met Fifth Avenue in an installation that invited people to step into the Met's latent space as a prototype for a way of interacting with these models that allows you to actually explore the suggestion space between works. And we also made a digital tool called Gen Studio. So this is what Hendrik mentioned, that allows users to explore the space between objects on a map of visual feature space, where interpolations are created by physically traveling between existing objects, placed kind of arbitrarily near each other in two-dimensional space. And once we create an object that we're interested in, we can explore similar objects back in the Met's real collection and compare generated objects to their physical counterparts or others in real space in the collection space that they might suggest. And that's still available online at gen.studio if anybody wants to check it out. So one of the next things that collaborators on that project and I have been exploring, so this is specifically with visual artist Matthew Ritchie, is the ability to take models like this, trained in some cases on finer, smaller subsets of large digital collections, and produce as artworks themselves alternate and imaginary histories of art built from these kinds of latent walks that can be produced in real time. So we actually just did an exhibition down in Texas called Florilegium, where we used robotic oil printing via a friend's oil printer in New York to layer time paintings or latent walks at different points near to one another in the latent space of a style GAN trained on sketches from the Met collection, and made individual time paintings of particular walks through space as a way of doing what I suggested and iterating on a collection that already is, so the Met collection of digital sketches, modeling it, and then using that model to produce next steps, maybe, in the evolution of that archive space. So this is displayed down in Texas, but one of the other, broader questions we can ask when looking at models like this is the set of concepts that they contain. What's in these models that allows them to approximate the evolution of Babylonian cuneiform tablets, if you see here on the right, or medieval art in Europe in the 11th to 13th century? What are they representing in order to do this? And I'll pause here to answer any questions about projects we've already seen before moving forward. But I think moving into the second half of this talk, we'll think about starting to explore what's going on under the hood in some of these models, which themselves are powerful tools for engaging with artistic structure at the level of reproduction, right, and extrapolation. But next we'll ask what they're leveraging under the hood in order to do that. So let's see, maybe there's a question in the chat, or Hendrik.
I kept monitoring so far. I think there are no.
And so far. Okay.
I have a question. It's Michael. What an interesting talk. Thank you so much. The question is, have you looked at doing something like this with the design of letters? I'm thinking there's so many different fonts, and before humans knew to say fonts, styles and ways of making letters. And we know there's not only 26 letters in multiple alphabets, there's just 26 letters in North America among Euro-Western people, blah, blah. So I'm thinking letters sharing features with other letters. Can you back predict existing letters beyond the 26? And you can see where I'm going. So I'll stop talking and let you talk. Thank you.
Well, that's a wonderful suggestion, and maybe somebody else in the audience here would have other ideas or would want to try something like this. I haven't. Maybe the closest thing I've considered that to what you suggested is looking at, and you can see a tiny hint of it here in that embedded video, in the evolution of writing and of early letters in Babylonian cuneiform tablets. And this is something done in collaboration with Ken Benzel, who I mentioned, who's curator of ancient Near East collections at the Met. And she pointed out to me that there was a specific point in time before BCE And at that point in time, picture making on cuneiform tablets switched from pictorial representations of concepts in the world to specific letters or more letter-like symbols, right, that could be recomposed. And that switch to something that looked like early language is something we wanted to see if we could capture in one particular dimension of a generative model, and then apply that feature, right, to steer creation through latent space to novel tablets or to novel pictures and transform them into something that looked more like letter space, and hypothesize what that switch from picture making to letter making might have looked like if it had happened at different points in time with different theories of underlying picture space. But I haven't done anything like that with more recent alphabets. That'd be an excellent project to try.
I hope you do, and I hope it's fun. Thank you.
I think I can post a link in a second or so from a person called Rafa, who's working at Google. He did something on letters in scalable vector graphics, and I will post a link here in the chat.
Great, thanks, Hendrik. All right.
There was a question from Lydia.
Sorry, from Lydia. Do you remember any reactions from the people who visit the exhibit? What did it make them think, feel, experience?
There was a lot of interest. You know, we did this at the Met in the Great Hall, and then also put it up online. And I think I mentioned before that curators especially were scared of this project when I first proposed it to them. And their initial reaction to just the concept of using AI to explore interstices in some collection was horrifying, right? Because they spend their lives designating differences between objects created by some group of people at some point in time. And the thought that we might come in and smash everything together and not pay attention to the structure in their archives that's so precious to them, I think inspired a lot of early resistance to the project. But as it developed, and as we showcased it in the Met, I think there was a lot of appreciation for kind of the cultural nuance that can be experienced in these models. And this project definitely didn't take it all the way there, right? But it suggested future possibilities for embedding interpolations in historical context. And so even from within the museum, there was a lot of excitement about these kinds of possibilities and the beauty of them. And that's what inspired kind of the ongoing collaboration I have with Kim, exploring AI in the context of a very ancient relationship to making. And I think more broadly in the public, there's been a lot of excitement to extend this project to other museum digital collections, which is something I'm in the process of doing that I'm very excited about, but poses a lot of challenges because accessing these museum APIs, though they're great, comes with a lot of rate limits and challenges for amassing what we could think of maybe as a foundation model for art or for human creation, where we could explore not only the collection in the Met, but collections across other cultures and that aren't so Western dominated. So these are, I think, ideas that a lot of people are excited about that they voiced, you know, in response to this project that we're in the process of considering. If anybody wants to speak about those or join that collaboration after this talk.
Great answer. Can I just follow up? I'm now real, not hiding behind the Zoom chat. Well, I'm so interested in this because AI reaching the public in ways that they can experience, I think, is important. We have been taking GTP3, which is very exciting and scary, and all the feelings to some of the journalism students, and almost every one of them has the same like user journey experience, where first they're scared, and then when they actually get to see it and play with it, they're like, oh, now I get it. And so and then they like feel like, oh, okay, here's something that could be useful about it. And so I feel like it follows I don't know if you've heard of like the Grauman hype cycle. At first, everyone's excited, scared, whatever about the technology. But then once you experience it and see it for yourself, and you're not just like hearing Elon Musk's echo chamber of media fear, you see it in a much different way. That personal connection to seeing it and exploring it, I think is really important, because as AI is going to become more and more important in kind of everything. That fear needs to subside, but not enough people have AI in their hands to play with, to experience.
I agree. I've been starting to play with GPT-3 myself just in the beta. And even some of the examples, you know, if you just skim these online, really don't capture the user experience of kind of interacting with some of these tools. And I think that giving people the opportunity to collaborate and feel like, you know, in the context of this workshop, they have some kind of creative superpower, right? But what is that actually? That they can take some idea and experiment with extrapolating it or completing it, which is what a lot of these tools at this point give us the capacity to do. And feeling like you're acting in parallel with possibilities for completion of an idea or replication and iteration of some embedded concept is a very powerful thing. And part of my thesis here is that it's not something that's unique to generative models, that it's inherent in building shared culture and sharing artwork and producing artwork, but that it's not something that many people have explicit, controllable access to. And what we can do when we put them kind of in creative dialogue with deep networks or generative models is allow them to access these kinds of latent structures that I see as underlying a lot of creation, and give them the ability to manifest that in some product, be it, you know, images or text here. And I think once people experience that, it won't feel so foreign interacting with AI as a foreign thing, but more interacting with executable concept space, if you will, where we can design kind of increasingly interesting ways for people to project concepts that are interesting to them into the representation spaces of these models, and then use the models to extrapolate these concepts further, right, and iterate upon them. I think that's where a lot of the magic is that'll get people excited.
Very cool, thanks.
Yeah. Nice to take a pause mid-talk here, but I'll continue and we can resume discussion at the end if there are any more questions even related to this first part. So as I suggested, next we'll think about what's actually going on under the hood in GANs or other models trained, you know, in my domain largely on visual work, but we can ask similar questions about models that handle audio or text. And in general, one of the things I've found when looking at this field is that when we're considering art and human perception of creative work, we need slightly different approaches to interpretability in these kinds of domains, where it's a little bit harder, given the nature of the work, to use off-the-shelf toolkits to search for meaningful visual structure. And what I mean here is that a lot of approaches to interpreting units in deep generative models rely on like existing labeled data sets of what we might expect to find in them, that grew, in my case, out of computer vision work, which is very valuable when interacting with real world images. But when we're looking at, I'll move back to the slides here, right, when we're looking at something like a painting and we want to see what a node represents in a deep network, some unit in an intermediate layer, it would be difficult to find in, for instance, this Turner painting, a hard edge between regions of the image, right? What would an edge detecting unit do when encountering a painting like this? And when I look at this, and maybe when you do too, or one of the better known Picassos, you have a whole breadth of visual experiences occurring on top of these works, right? And there are ones that are in some cases a little bit difficult to articulate. Maybe when thinking about the depth of this piece here, I can appreciate that, you know, maybe this window in the back is further behind whatever's going on in the foreground. Maybe it looks like a fire here. And I can also start to appreciate kind of the mood of the scene. But when we describe, you know, in cognitive science, how humans appreciate visual structure in pictorial space like this, it's actually a pretty difficult problem, because we can't do it by inverting optical principles alone or using something like a physics engine to explain what's going on in these kinds of scenes, because some of them are more abstracted, right? And we don't even have a lot of traction on more symbolic models that underlie visual representations in more abstract scenes. And so I won't spend too much time on this point, but just as maybe inspiration or a point of discussion for us, I think one potential beauty of using deep generative models to capture human creative work is that they might allow us to start getting some kind of traction on representations that humans use to do what we do very well that current AI cannot. For instance, recognizing infinitely many abstract renderings of a common shape, like these figures, that are no problem for us, but pretty difficult for sketch models that can appreciate simple sketch representations, but that don't do so well when we start moving into purer abstraction. So to start, getting into this problem, I mentioned that we might want to reconceive interpretability work as more of a dialogue between humans and deep generative models, or an exploration of concepts that exist inside of them that are also meaningful to humans. And a lot of you are probably very familiar with existing work to identify interpretable directions in latent spaces of GANs. So wonderful work finding steerability within latent space, where we can steer images to move more in directions of common concepts like zoom, increasing the zoom of an image, or the brightness, or maybe rotating it in 3D space. There's other work that explores maybe even higher level concepts like the memorability or aesthetics of an image. And a lot of these earlier works use off-the-shelf classifiers, so even ones trained on memorability scores of different images, to drive optimization of some direction in the latent space, which depends on some finite or predetermined set of concepts that we're searching for in a model's representation. And other approaches still have used unsupervised methods to find disentangled dimensions of variation in a model. And though these are very interesting, their salience to human observers is not baked in. It's relatively unknown, and experimenters might label them after the fact. But we might not be able to consider that these representations that are most significant to a model are necessarily ones that would have meaning to different users. And so this is a project that I worked on with David and a couple of other people from MIT CSAIL last year. And I'm going to share our approach that I think could be useful to starting to identify sets of concepts in generative models, not only trained on real world scenes, but trained on other domains like creative work, where to really understand what's going on under the hood of a model, we would need to build what I'm calling a shared vocabulary that captures concepts that are meaningful to humans, and that also exist in a model's representation. And then we might be able to use that vocabulary to interact with the model along dimensions that are in a built-in way meaningful to humans in the representation space of the model. So I'll quickly run through the procedure that we defined for how to do this. There are a lot more details in the paper if you're interested in reading more. But first, what we do here is identify a set of directions in the model's latent space. So we'll be working with GANs in this example, trained on images. And we identify a set of directions in the model that make minimal, meaningful image transformations at different levels of abstraction. And I'll unpack all of these in a moment, but just to give you a high level idea, the next thing we'll do is collect human annotations of these directions, and then we'll decompose these longer form annotations into a visual concept vocabulary consisting of primitive directions labeled with single words. And lastly, we'll do some human studies to show that these concepts generalize across latent space and image class and can be composed to create novel transformations that work present in the annotation data here. So to begin, we generate a set of directions, as I mentioned, for humans to annotate. And this is where we'll project concepts that humans find meaningful in visual scenes onto the representation space of our generator. And here we used Big GAN trained on ImageNet and Places data sets. But the method is pretty model agnostic and could also be used on Big GAN trained on a data set of art, for instance, which is something I'm exploring now. And to gather this initial set of directions for annotation, we could choose them randomly. So just sample 2 points in space and interpolate between them, or we could be a little more careful. And because our ultimate goal here is to learn a vocabulary for interaction with the model that's both diverse, including changes in color, texture, composition, and perspective, and pretty specific, where the same direction or the same transformation will reliably elicit a particular change, we construct a set of what I'm calling layer selective directions. And these directions have 2 key characteristics. First, they minimize change in the GAN's feature representation at some intermediate layer L, so they produce specific changes in the image. And second, they're constrained to be orthogonal to directions selected for other layers. So we're kind of carving up mutually orthogonal subspaces of the latent space to capture changes at multiple levels of abstraction. So we might see here in layers closer to the image output, we change more fine-grained things about images like wall color or color and texture of a bedspread in a bedroom. And as we move earlier, through the network, we might add different objects. So add more paintings to the wall, right? And then as we move even earlier, we'll start to do things kind of at a coarser grain. So changing the 3D rotation of the room, changing zoom and perspective. And while the rest of our method can extract these kinds of isolated concepts for specific transformations from any corpus of annotated directions like this, using these kinds of layer selective directions produces a more diverse vocabulary when humans produce annotations of them, with greater semantic similarity across annotators than either using random sampling methods like I mentioned, just picking 2 points in space and interpolating between them, or using principal components from the model's feature space. So to begin, we generate a set of annotated directions on Mechanical Turk. And you can see examples here from 4 categories in Big GAN places that kind of capture a mix of indoor and outdoor scenes. And human annotators will produce annotations like snow is added and the sky is electric blue with eerie dark clouds and it looks colder. And first, these annotations are pre-processed and lemmatized, producing a set of multiple concepts associated with that transformation. But these sets of concepts are still complex, right? You still have a handful, 7 to 10 concepts associated with each direction. And we need to disentangle them to produce a vocabulary of individual concepts that can be used to produce related image transformations. So next, we'll disentangle these concepts to construct our vocabulary. And we can formulate the learning of the vocabulary as a regularized linear regression. And so we have a word matrix W, and let that word matrix have entries that specify if some word J is present in an annotation I. And let E be the matrix of embeddings we're solving for. And we can compare WE to D, where rows of D are the annotated ground truth directions, and solve analytically for E, and then just read off embeddings of individual concepts in the latent space. And remember, we can use any of those concepts in addition to some initial latent code Z to transform that image either in a positive or negative direction according to some concept in the latent space. And so here, if we started with an example at compound annotation that describes the transformation of this nighttime market scene as making it have greater contrast, maybe a little more colorful, adding more people, and it feels more inviting and more festive. So via our disentanglement process, we can extract the individual transformation corresponding to festive. What makes this scene festive? Which might be hard to write down, right? Before looking at what humans determined produced a festive change. But via this process of labeling and disentanglement, we can, extract this single concept and then use that to transform any new scene along a festive direction. And applying this process to just our small annotation data set yielded over 2,800 distinct visual concepts. And you can see some examples here across different categories inside Big GAN trained on places, some that are common to all image classes, like changing images to add a particular color, and some add concepts that are maybe more particular to an image class, like adding an arch to an outdoor street scene, and some that span seasons and even kind of higher level qualities of scenes or moods, like making a lawn more manicured. Or making a kitchen more modern or more inviting, and aspects of physics like adding a reflection to a lake or making it foggier. And interestingly, all of these concepts are kind of captured in the same representation space, high level things like moods of scenes, the invitingness of a kitchen, to physics, reflections on a water, and color like making a scene more blue or adding something like a sunset. And these are all kind of condensed into a compact vocabulary, which we don't claim is complete yet, but sort of a first attempt to systematically categorize a set of concepts that you might find in a given generator that could allow humans to interact with that generative model along dimensions that they find meaningful in visual scenes. And in the paper, we go through a series of pretty involved user studies to show that this vocabulary has a couple of important features. I won't spend too much time on them here, just keeping an eye on the clock. But we show that concepts created in this way generalize across latent space. So learned at one point in space, we can apply this concept to another starting point in the latent space, and humans actually recognize these through a series of experiments we did on Mechanical Turk with far above chance accuracy across all different image classes and across lots of different viewers per image. And so these concepts do generalize across the latent space. And we also show that they generalize across class. And subjects recognize concepts across image classes kind of more robustly when the concept initially appeared in both classes, but still successfully when it did not. And just to show you a couple of examples of this without getting too much into the weeds, say we take a concept that's learned in one class of big GAN places, like the cottage category, and then we want to apply that concept to classes where it wasn't seen. So asking if we can generalize this dictionary of concepts across categories of images. And so we might apply it to the kitchen category, where it was also seen in the annotation data set, and we're able to add yellow to a scene there. But what if we take snow, which is learned in the cottage category, but didn't show up in any human annotations of Medinas or of outdoor marketplaces, and we can still add something like snow to this to the kind of category where it wouldn't be likely to appear, so to an outdoor marketplace. And there aren't many places in the world where that would be possible, but it's the kind of extrapolation we can make in some cases in a generative model. And to go back to our initial example, we can apply this kind of festive change that we learned in an outdoor marketplace to something like a cottage, right? And add a red roof and I think a ribbon on the exterior gate here that also make this scene semantically more festive in the minds of viewing users. And finally, we show that concept compositions are recognizable by subjects, regardless of whether concepts co-occurred in the annotation data set. So we evaluate this by composing pairs of target concepts, both with each other and with distractors that were randomly sampled from our vocabulary. So you might sample two concepts, targets festive and arch, and then compare the composition of those to the composition of festive with a distractor and the composition of arch with a distractor. And then finally show subjects the composition of those two distractors and ask them which generated image best matches the named target composition. And users select the target pair the majority of the time, but interestingly, partially correct compositions of one of the target words with one of the distractor concepts are preferred over pure distractor combinations, suggesting that this visual concept vocabulary does have some of the features you would expect of a useful open-ended vocabulary where the concepts do decompose faithfully. And the compositions are recognizable regardless, unlike in the class generalization, regardless of whether the concepts co-occurred together in the annotation data set. So you might have concepts like arch and people that annotators did use in the same sentence to describe some transformation, and then we can recombine them when generating novel compositions. There are other examples like snow and people that did not occur in the same annotation of outdoor marketplace scenes, but we're still able to compose these two concepts faithfully in a way that human end users recognize them as doing kind of what it said on the tin, right? Adding snow and people to the scene. And if we add the combination of festive and arch to our original outdoor marketplace scene here, something to me really interesting happens. We don't just add a crowd, right, and add decorations. We actually make the arch itself more festive, suggesting there's additional kind of exploration to be done here about the ways in which the concepts compose and kind of the semantic topology of the related latent space and how different concepts might compose differently with their neighbors based on how they're organized in latent space. But to think about how a vocabulary like this might be kind of broadly useful for interacting with a generative model if you've found a shared vocabulary between some set of human users and that model. And this method is quite useful in general because you can specialize the vocabulary that's learned for interaction with some model to a particular user group. And so maybe experts who have particular knowledge about some corpus of artworks or some textual corpus, if you were doing this with text, and find a vocabulary that represents kind of the projection of their specialist knowledge into the representations that are possible in the space of the model. And I envision tools of the future that could enable kind of concept manipulations with concepts that users themselves define. And so a really exciting example of painting with concepts that I'm almost sure everybody here has seen, is David and Hendrik's GAN paint application that allowed users to manipulate an image semantically with a paintbrush that applied not just paint, not just random pixels, but a concept to a scene. Like here, I marked a part of this church scene and added a tree on a little grassy patch in front of the church. Now, this kind of manipulation of real world photo content where users can also upload their own photos kind of relies here on a predefined set of labels that they determined, right, when interacting with this model and understanding what kinds of things the model represented that could be applied to scenes. I'm suggesting that what might be interesting for the future of co-creation with generative models is content manipulation with concepts that users themselves define. I mean, I think we're already seeing a lot of this with vision and language right now, but the ability to semantically edit images here, not with these kinds of predefined concepts, but with elements of a vocabulary that maybe some user group defined, capturing their own relation to the representation space of a model. So it would be fun to think together about other ways to kind of discover concepts that would be relevant to some user inside a large model, like a GAN or even a textual model. And a question I want to leave us with is whether language with vision here is always necessary, and whether there are some classes of concepts or experiences that you might have, in this case of visual scenes, that would be difficult to capture with language, but could still be replicated, transmitted across people, and even categorized, right, in conceptual space, even if we don't necessarily have language for it. And Hendrik and I actually did a project that started to explore this idea a couple of years ago, looking at few-shot learning of visual concepts inside a GAN's latent space. So we took big GAN trained on Places 365 here, and the idea is that we can sample images from some category in this generator's latent space and allow users to kind of sift through a pool of generated images and sort them according to some distinction or some concept that they recognize in this pool of in this pool of images, something that's visually meaningful to them, whether or not they have kind of a concise term for it. And so here, in this example, I've sorted just a few exemplars of scenes I find, kind of more dreary or more wintry, as opposed to ones I find, not necessarily summery, but more fertile and more vivid. And we can learn a distinction between these two groups of images just by training an SVM on their associated latent codes in Z space. And then a normal to the hyperplane that the SVM learns is a direction in the latent space of the model that transforms any new image kind of along that concept direction in the model's representation space. And we can also do this in intermediate layers. We're not limited to the latent space. And instead of training on latent code Z, we can train on activations in feature space of some intermediate layer of the model. And in doing this, and steering activations of some internal layer along directions that capture separations between concept classes, we can make kind of more fine-grained changes to images. If you see in this example here, steering toward the more kind of vivid or summary direction. Doesn't change so much structurally about the scene as if we do it in Z space, even though we're still adding kind of semantically appropriate changes to each image. And we built a quick web demo of this kind of idea called the Latent Compass. I think it's still up online if you want to check it out. But the basic idea here is that users would sort images, and it's already been done in this example, into classes on the right and left of the screen, just by dragging and dropping them. So here capturing the difference maybe between a flat beach on the right and a rockier coast on the left. And I can drag and drop images even from other classes, so like a lake, into the middle of the screen and then steer them along the directions of these concepts I've defined just with visual examples. And you don't need very many here, only like 6 of each class. Here's another example. I'm quickly sorting closets by whether or not they're full or empty. So I've got full closets packed with clothes on the right, and then empty closets are on the left. And I'm going to learn a direction that might be able to transform new images along this fullness dimension from full to empty. I can test it out with new closets, and it is adding clothes when I drag a new closet image to the center of the screen. But another question we might want to ask is, at what level of abstraction has this concept been represented? If I drag an image of an outdoor marketplace into the center of the screen, will it add clothes to it? Or will it add whatever is appropriate in that category to add visual density or fullness to the image? And if we test this by dragging an image of a Medina into the latent compass, we end up adding not clothes, but more people to the scene. So maybe the model knows something here about fullness in a relatively abstract way that allows for translation between domains. And just by entraining this concept through a few exemplars, we leave ourselves in this tool with sort of a representation that we can use to steer through conceptual space in a new image. And this is something I hope we can capture sort of in the future of creation with generative models. And to end, let's think a little bit about the advent of other technologies that challenged the state of creation at different points in history, like a lot of artistic tools for creation with generative models are doing today, as we discussed a couple of examples of artists or others getting scared when they see potential replacements of their work. Well, this isn't a new thing either. If we look at painters before the advent of photography, who in the academic school thought their job was to kind of reproduce reality on a canvas as faithfully as possible. And after Daguerre introduced the first early photographs or daguerreotypes in 1839, painters first saw this new technology as a dire threat. Oh, we're out of a job, right? This machine is going to replace us because it's doing the thing that we're supposed to do. It's capturing reality and putting it on 2 dimensions that we can then share, right? But not too long after, the poet Baudelaire said that pure representations of reality are merely phony simulacra of what's really out there. Or in other words, artists should aim to paint not what they see, but something maybe more human, right? Or something where the mind plays a role, what it is like to see it. And with this, we saw the advent of Impressionism and after abstract Impressionism, where paintings didn't capture faithful representations of pixels in the real world, but more what it was like for the artist to see, in this case with vision, what it was like for the artist to see that scene at some time, right? And so even in the work of Cézanne, we find examples of superimposing multiple perspectives in a single image, which is something we also see with Picasso, which might not be a faithful representation at the pixel level, but might more faithfully communicate the experience of what it was like to see a scene on a table, maybe after a messy meal. And in the 20th century, photographers started using this tool that we first thought could faithfully capture reality to do something a little more abstract. So here we've just got a quick example from Minor White. And this is a photograph, but without the title below it, it might be difficult to kind of understand what exactly the scene was a photograph of from a representational perspective, but you can tell what the photograph is like. And you can start to name or cluster qualities that this scene has that you might also appreciate in other visual scenes. And now we start to see artists using AI in kind of a similar fashion, where what's represented is not just pictures of the real world that again might be able to reproduce faithfully at the pixel level, but aspects of what it was like to encounter some visual stimulus that can be maybe found inside a generative model and used to modulate future creation along these dimensions. And so I envision sort of a future of creation using AI in this way, where what it is like to see or what it is like to experience in different modalities is something that's replicable or transferable or manipulable, and part of the artist's palette that's both grounded in a particular context and generalizable beyond it. And so maybe toward a future of co-creating with deep generative models, things we can think about are models for making that can now be collectively curated across large groups and shared, allowing a kind of cultural experimentation that I think takes place in analog to now happen at unprecedented speed digitally. And additionally, maybe we can discover concepts inside deep generative models that capture aspects of human experience, what I was talking about here, that transcends reproduction of pixels, but rather captures what it is like to engage with that stimulus. And when we can discover them inside deep generative models, we can instrumentalize them and share them by reproducing transformations across different varieties of inputs. And I've only shown some first examples of how that might play out here, but these are directions I'm very excited about and would love to talk to anybody else about in our discussion. And to wrap up, I'd like to thank all of my wonderful collaborators on this variety of projects, both from MIT, from the Met, from Microsoft, colleagues at the Berkman Cyber Law Clinic at Harvard, and artists I've collaborated with. And thank you all for listening today.
I'm doing the one person clever. I hope it's for
Thanks,
people in the call. Thank you, Sarah. That was pretty cool. I have a couple of questions here, but also want to encourage you to maybe just use the raise hand feature or put your question in the chat if you have one. I mean, one question is a little bit on a very high and meta level, because since a while I have a discussion with my PhD advisor about like what is art in this kind of context. And so far it seems that we are getting AI as a collaborator pretty much in the way of saying, okay, you can learn about the craft of creating an artistic artifact and learn it from a given distribution. So essentially, you can only stay within the realms of what is already known and interpolate between that. So the question is, what do you think would be needed to have an artistic or creative output of a model that is not only based on what it already knows, and therefore not only acts as a kind of muse, but also more as something that is new, that is inspiring?
And I think we could have a kind of a deeper discussion about the creation of novelty itself, right? What is it like even to encounter a new experience or to create something new as a human artist, not working with digital tools? If we see kind of the output of that person's process, what about it would make us say, oh, it's quite new. It doesn't look like just a summation of what that person has seen in their life. If we could ever appreciate all of that and filtered through their own lens, I think you could think about packing all sorts of those kinds of transformations under the hood of some model so that you would push it toward divergence from a set of inputs, right? And encourage maybe more randomness in its extrapolation. But I think you also might need, just like in broader AI, something a little more structured than extrapolation or, pattern continuation in order to produce something that draws on some underlying world model, but also produces something that isn't just pure combination of things it's already seen. But I do think we could approximate that or get a lot closer to at least the experience of it by allowing for kind of more rapid collaboration and iteration with models than we already have now, right? Because a lot of the pipeline for interacting with models like this, even for artists, is like training once and then hosting or deploying this thing somewhere online and either giving other users access to it or creating a series of works in collaboration with this model that really kind of capture one point in time. And I think if processes for contributing new material to some models, training and retraining quite quickly, and iterating and producing new works that then feed into training of future models, having that pipeline be kind of quicker could allow the human in the loop there that's making decisions about what output to curate and enter into the next cycle of the model to really play, at least for the short term, the role of novelty, right? Or play the role of really producing something new. And I don't think we're there right now in our infrastructure for collaborating with models. I mean, platforms like Hugging Face are starting to get part of the way there, but we really need ways for people to contribute to and to iterate upon models that have already been trained to start to see what this could look like, and then maybe inspire building into AI stronger structural world models that could produce novelty that I don't have immediate answers to.
Yeah, I think this is also probably, as you mentioned already, a discussion that could take a couple of hours. So probably we save that for a later time point. Sorry for bringing it up. I have one question from the chat, and then you, when it's your turn. From the chat, Mary Lou asked.
Can I ask my question, Hendrik, please?
Yes.
Thank you. Hi, this is Mary Lou Meyer. Thank you so much. I really, really appreciated conceptualizing this as shared models of making. And I particularly like the idea of getting the concepts and the vocabulary of the images through Annotations by Amazon Mechanical Turk. I think that really does emphasize that concept of shared mental models. However, I wonder, we're talking about the artist is not necessarily the Turker, and the Turker's not necessarily the artist. So there's a question about that alignment with the annotations and the concepts that provide meaning to the artist, without saying they should, because I love the shared mental models idea that the images that we use to train our neural networks, if they're just the digital representation and it doesn't have those concepts tacked onto it, then you're right. Then it generates things that may not have good meaning or be easily interactable, if that's a word, with artists. But what about that alignment? Is that important? Did that happen?
Yeah. So, I mean, I agree. These AMT annotations don't necessarily capture concepts that some individual artist would appreciate. I mean, they might, especially if we're working in that case in the domain of real world scenes, right? Where specific things like adding reflection to a water might be pretty universal, right? Or adding shadow to an alleyway. But those higher level correlates of the mood of a scene, like we saw some examples of making a kitchen more inviting or more modern or warmer or things like that. I mean, we can measure through limited human user studies, like whether those visual representations of semantics do generalize across the population. But that's just the population that, we're looking at on Mechanical Turk. But I think what I'm suggesting with that process is not that any one set of shared concepts would be relevant to some creator, but just that the method for distilling a set of concepts that's particular even just to you, if you want to annotate a whole lot, or maybe we can leverage things like Clip or other models that could provide more automatic annotations that you could guide, but that process is not very difficult. And to approach a new generative model with the intent to create a shared vocabulary, even just at the individual level between you as an artist and that model, then you could interact with it along the dimensions of concepts that by design are meaningful to you, right? So I don't know if, especially because the annotations we found pertained to big GAN places and big GAN ImageNet images. Maybe artists wouldn't want so much to use that and would want to use concepts that you found inside big GAN trained on collections from museums across the world, right? Digital collections like that. So we would need to repeat that process where people would describe concepts they found meaningful in artworks or artistic objects. But it's more of a pipeline I was suggesting for doing this again, and with experts or different groups who would want to find their own representations of meaning.
Thank you.
Yuwen, I hope you pronounced your name correctly.
Yeah, that's right. Thank you very much, Sarah. My name is Yuwen. I'm a first-year PhD student at the University of Notre Dame. My advisor is Toby Lee. I work in the area of using AI to facilitate UX practitioners' work, so less creative or aesthetic, but more practical focused. So as a first-year PhD student, I just want to ask, this is a really impressive body of work. How did you get to, or how did you manage to learn so many different dimensions that's involved in your work, like different disciplines, and get all these different skills that you need? Because I'm having trouble wrapping my head around GAN. Also, how did you make these connections inside and outside of your institutions to make these collaboration work possible?
Thanks, Ewan. So I think the quick answer is like by not doing what my department wanted as a grad student, which is both a blessing and a big curse, right? So if you take an approach to kind of crafting your own body of work that really draws upon kind of interdisciplinary interest, that for me wasn't intentionally interdisciplinary. It was more about, thinking about sets of core questions that either transcended or underlaid, however you look at it, different fields. And for me, those core motivating questions were ones about like the nature of the human relationship to the world, right? And whether that's a creative one. And if so, can we find evidence of that in like fundamental perception? And also kind of at a higher level in the creation of experiential worlds in art. And then what computational tools would we need to both capture those creative processes and to kind of remix and modulate them? So I went about kind of fleshing out that pipeline for thinking about this at different scales in a way that doesn't feel satisfyingly complete to me yet, and probably never will, but is an approach that kind of starts asking the same question in different domains. And so it didn't feel like string a whole bunch together. It felt like asking the same thing in different ways, if that makes sense. And in terms of how I meet people, you know, I think that process is just a byproduct of asking that kind of core question in different venues. And then after doing one project, kind of really paying attention to its successes and failures and its ramifications in your environment, which is something I think you can do anywhere in projects you're engaged in. And if there is something that went particularly well or that was particularly challenging, like chase it up and think about what infrastructure would be needed for that to go differently in the future, and how you might build and provide that for others and who you might need to talk to do so. And that's how I meet a lot of people, right? Finding the people that could help build the world that would realize your vision, and then starting that process with them. But it's very kind of question and vision driven rather than disciplinarily driven, if that makes sense.
Cool. I think there are still some questions coming in. I will forward them to you. Sarah, I already started collecting emails. Thank you very much for the presentation and for the questions and the discussion. I think it was a wholesome experience from all kind of angles. And I'm only left with saying that it was a pleasure to have you, and that I think officially in 2 minutes we would start with the next session. But I leave it up to Werner to say what the real time
Please
is.
take a break. I can also respond to other questions in the chat or by email. Thank you so much, Hendrik, and everybody for your time today. This was such a pleasure.
Thank you.
Thank
I'm
you.
gonna stop the recording now. All right.